Hello, in this lecture we will find out the size of angle theta. In the drawing we have a quarter. Inside this quarter we have square ABCO. We also have angle AMQ that equals to 90 degrees and angle BQO is equal to theta, and we want to find out the size of angle theta. So first of all we will make the construction. We will extend QO and MA by a straight line until they intersect with each other. Okay, so we'll extend line segment QO by a straight line, and we will also extend line segment MA until it intersects with line segment QO, and we'll define the intersection point between extended QO and the extended MA as point N. So actually here, if we complete the quarter circle to a semicircle, then you can see that we have here a semicircle, and actually we have a semicircle, and in this semicircle that we created here we have peripheral angle NMB, angle NMQ is a peripheral angle, and any peripheral angle that is equal to 90 degrees, like this angle, must rest on the diameter of the circle. So we actually have rule number 1 that states that a peripheral angle that rests, a peripheral angle that equals to 90 degrees rests on the diameter. Angle NMQ, this angle is equal to 90 degrees, and therefore this peripheral angle that equals to 90 degrees must rest on the diameter of this semicircle. That is to say, NQ is the diameter of this semicircle. So I write it down. We have rule number 1 that states that a peripheral angle, or any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So, and because of the fact that the peripheral angle NMQ is equal to 90 degrees, we can conclude from it that it rests on the diameter. That is to say, NQ is the diameter of the semicircle. NQ is the diameter of the semicircle, so here we know that the diameter is equal to 2 times the radius. So if we define the radius of this semicircle as capital R, then we know, because of the fact that we have here a quarter circle, this is a quarter circle, therefore QO must be equal to the radius of this quarter circle or semicircle, it does not matter. So here QO is the radius of this semicircle, that is to say it equals to R, and NO is also the radius of this semicircle, that is also equals to R. Because of the fact that we have here a quarter circle, then QO must be equal to R, and if QO equals to R and NQ equals to 2R, then NO must be equal to 2R minus R, that is R. So NO is the radius of this semicircle, and QO is also the radius of this semicircle. Okay? And in the right triangle QMN, this right triangle, we know that the sum of the angles must be equal to 180 degrees. So here, which angles we have in the right triangle QMN? We have 90 degrees plus this is angle theta, plus this angle that we define as angle x. In total, the sum of those three angles must be equal to 180 degrees. So here we subtract from this equation 90 degrees, and we get that angle theta plus x is equal to 180 degrees minus 90 degrees, it is 90 degrees. We subtract theta from this equation, and we get that angle x equals to 90 degrees minus theta. So we found out that this angle equals to 90 degrees minus theta. So we substitute x by 90 degrees minus theta. And we also know that all the angles inside a triangle are right angles. Therefore, in all the angles inside a square are right angles. Therefore, in square, all the angles inside the square are right angles. So in square ABCO, all its angles are equal to 90 degrees. So those angles are equal to 90 degrees. We have already found out that NQ is the diameter of the semicircle, and NQ is the diameter of the semicircle, must be of course a straight line. So I can write down that NQ is a straight line. And we also have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line NQ, if we focus on the upper side of the straight line NQ at point C, then the sum of the angles must be equal to 180 degrees. So each angles we have in the upper side of the straight line NQ at point C, we have here 90 degrees. Plus this angle that is actually angle BCQ. In total, the sum of those two angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Here we subtract 90 degrees from this equation and we will get that angle BCQ, the missing angle, is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that angle BCQ is a right angle, it equals to 90 degrees. Likewise, if we focus on the upper side of the straight line NQ at point O, this point, the sum of the angles here must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at point O? We have here 90 degrees. Point O. We have 90 degrees plus the size of angle AON. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Here we'll subtract 90 degrees from this equation and we'll get that angle AON is equal to 90 degrees. Angle AON is equal to 90 degrees. This angle is a right angle. So if we focus on the right triangle, triangle AON, we know that in the right triangle, triangle AON, the sum of the angles must be equal to 180 degrees. So here we will define the missing angle as angle X. So we can write down that angle X plus 90 degrees plus this angle that is equal to 90 degrees minus theta. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled. So here we have x minus theta equals to 0. We will add theta to this equation and we will get that angle x is equal to theta. So we can substitute angle x by theta. So this angle equals to theta. Likewise, in the right triangle, triangle BCQ, the sum of the angles must be equal to 180 degrees. In triangle BCQ, we will define the missing angle here angle CBQ is angle Y. So the sum of the angles in the right triangle, triangle BCQ, must be equal to 180 degrees. So which angles we have here? We have angle Y plus 90 degrees plus angle theta. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We will subtract 90 degrees from this equation, and we will get that y plus theta is equal to 180 degrees minus 90 degrees. It is 90 degrees. We will subtract theta from this equation, and we will get that angle y equals to 90 degrees minus theta. So we found out that angle y equals to 90 degrees minus theta, so we can substitute angle y by 90 degrees minus theta. So you can see that all the angles of the right triangle, triangle BCQ, are equal to all the angles of the right triangle, triangle AON. Both of those two triangles have angle theta, and both those two triangles have angle 90 degrees minus theta, and both those two triangles have a right angle. Therefore, we can write down that triangle AON is similar, this is the sign of similar, to triangle BCQ according to angle similarity rule. Okay? And from the fact that those two triangles are similar to each other, we will conclude that NO or CQ over AO is equal to BC over, actually we have CQ over AO is equal to BC over NO. Okay? Because of the fact that triangle AON is similar to triangle BCQ, we will conclude that the following relationship exists between the sides of those two triangles. CQ over AO equals to BC over NO. Okay? So here we know that the OQ is equal to R, and here we will define one side of square ABCD as A, so all of the other side will be equal to A, because of the fact that all the sides of a square are equal to each other. So COQ is equal to R and OC equals to A, so CQ will be equal to OQ minus OC, that is to say CQ will be equal to R minus A. Okay, so here this will be equation number 1. So we'll substitute CQ by R minus A over AO. What is the value of AO? AO equals to A according to our definition. That equals to BC. BC is also equals to A. Over NO. What is the value of NO? The value of NO, the value of NO is R. So it is A over R. So we got equation number 1 that states that R over A, according to equation number 1, R over A minus A over A is minus 1, that equals to A over R. Okay? So here, if we focus on the right triangle, triangle AON, it is very easy to see that A over R is equal to tangent theta, so we substitute R over A is equal to tangent theta, so we substitute R over A in equation number 1 by tangent theta, so it is tangent theta minus 1, that equals to A over R. A over R, it is equal to 1 over R over A. Okay? A over R equals to 1 over R over A. And R over A is equal to tangent theta, so we'll substitute R over A in this side of equation number 1 by tangent theta, and we get the tangent theta minus 1 equals to 1 over R over A is tangent theta. Here we will multiply equation number 1 by tangent theta, and we get that according to equation number 1, tangent theta times tangent theta is tangent square theta. Tangent theta times minus 1 is minus tangent theta. And we'll subtract 1 here. Minus 1 equals to 0. So we got a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of this quadratic equation, general quadratic equation, and x is the variable that we are looking for, and we'll find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay? And in our specific quadratic equation, the coefficient a is equal to 1, the coefficient b is equal to minus 1, and the coefficient c is also equal to minus 1, and x equals to tangent theta. So we write down the tangent theta. The variable that we are looking for is tangent theta, so we write down the tangent theta is equal to minus b. b equals to minus 1. Minus 1 is 1, plus minus square root of b squared. b is equal to minus 1 squared is 1, minus 4 times a is also 1, times c is minus 1, over 2a, a is 1, 2 times 1 is 2. So in conclusion, we found out that tangent theta is equal to 1 plus minus. Here inside the root we have minus 4 times minus 1 is 4, and 4 plus 1 is 5. So it is square root of 5 over 2. So we have here two solutions that are possible for tangent theta. The first solution is tangent theta is equal to 1 plus square root of 5 over 2. And the second solution for tangent theta is the tangent theta equals to 1 minus square root of 5 over 2, that is actually negative number is less than 0, and here in the question itself we have this angle that is 90 degrees minus theta. You can see from the drawing that this angle that is equal to 90 degrees minus theta is a positive angle. So you can write down that according to the drawing, the angle 90 degrees minus theta is a positive angle, that is to say it is greater than 0. We will add theta to this equation and we will get that theta is less than 90 degrees, and theta is of course a positive number, so it is greater than 0. So we know that angle theta is between 0 to 90 degrees. And when angle theta is between 0 to 90 degrees, then tangent theta is a positive number. Here, tangent theta in this from 0 to 90 degrees, it is a positive number. And because of the fact that tangent theta is positive, it is a positive number, and the second solution gives us tangent theta that is a negative number, this solution is incorrect solution. We will cancel this solution and we will focus on the solution, on the first solution, that tangent theta equals to 1 plus square root of 5 over 2. So if tangent theta is equal to 1 plus square root of 5 over 2, then the angle theta itself will be equal. We'll use the computer in order to find out the value of tangent of theta itself. So actually know that tangent theta equals to 1 plus square root of 5 over 2. So here we have the opposite function of tangents, that is tangents minus 1, is equal to 58.28 degrees. So we found out that theta itself is equal to 58.28 degrees, and that is the answer to the question. I'll repeat again. The answer to the question is that angle theta is equal to 58 degrees minus 58.28 degrees. Okay, that is the answer to the question. So in the next step, I will summarize the lecture. Okay, so we actually have here a quarter circle, and inside the quarter circle in the drawing we have a quarter circle. In Inside the quarter circle we have square ABCO, and we also have angle QMA that is equal to 90 degrees, and we have also angle BQO, this angle that is equal to theta, and that is the angle that we are looking for. We want to find out the value of this angle, that is angle theta. So in order to find out the value of angle theta, we made a construction. We extended line segment QO and also line segment MA until they intersect with each other at point N. Point N is the intersection point of line segment QO with line segment MA. Okay? And we also made another construction. We completed the quarter angle, the quarter circle. We completed the quarter circle to a semicircle. So we have here a circle, a semicircle with a peripheral angle. Angle NMQ is a peripheral angle, and this peripheral angle is equal to 90 degrees. As you can see, it is given as the question that this angle NMQ is equal to 90 degrees, and we actually have rule number 1. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So this peripheral angle, angle NMQ, is equal to 90 degrees, and according to rule number 1, this peripheral angle must rest on the diameter of the semicircle. That is to say, NQ is the diameter of this semicircle. Okay? From rule number 1, we will derive that NQ is the diameter of the semicircle, and here in triangle MNQ, we know that the sum of the angles must be equal to 180 degrees. Which angles we have in triangle NMQ? We have here angle theta plus 90 degrees plus this angle, the missing angle. In total, they must be equal to 180 degrees. So here we have angle 90 degrees plus angle theta plus the missing angle, that is angle x. In total, they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that theta plus x must be equal to 180 degrees minus 90 degrees. This is 90 degrees. We subtracted theta from this equation, and we got that angle x is equal to 90 degrees minus theta. So the missing angle, this angle, is equal to 90 degrees minus theta. Then we focused on triangle BCQ. Actually, we know that all the angles inside the square are right angles. So all those 4 angles inside square ABCO are right angles. And we have already found out that NQ is the diameter of the semicircle. NQ is the diameter of a semicircle. It is absolutely a straight line. NQ is the diameter. It is absolutely a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line NQ at point C, then the sum of the angles on the upper side of the straight line NQ at point C must be equal to 180 degrees according to the rule that I mentioned. So which angles we have here? We have here 90 degrees plus angle BCQ. In total, they must be equal to 180 degrees. Okay? So here, we know that NQ is a straight line, so in the upper side of the straight line in Q, at point C, the sum of the angles must be equal to 180 degrees. Which angles we have at point C? We have 90 degrees plus angle BCQ. In total, they must be equal to 180 degrees according to the rule that I mentioned. We will subtract 90 degrees from this equation, and we will get that angle BCQ, the missing angle, is equal to 180 degrees minus 90 degrees. That is to say, angle BCQ is equal to 90 degrees. So we found out that this angle is a right angle. Then we focused on the upper side of the straight line NQ at point O. According to the same rule, the sum of the angles on the upper side of the straight line NO MQ at point O must be equal to 180 degrees. So which angles we have here? We have here 90 degrees plus angle AON. In total, they must be equal to 180 degrees. Here 90 degrees plus angle AON. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. We subtract 90 degrees from this equation, and we get that angle AON equals to 180 degrees minus 90 degrees. It is 90 degrees. So we found out that this angle is a right angle. Therefore, triangle AON and triangle BCQ are both right triangles. And then we focused on triangle AON. In the right triangle, triangle AON, we know that the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle, triangle AON? We have here angle theta, we have here angle, no, we have here, this is actually the missing angle that we define as angle X. We have here angle that equals to 90 degrees, and we have this angle that equals to 90 degrees. So in total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Angle, again, angle X plus the angle that equals to 90 degrees plus 90 degrees minus theta. In total, it must be equal to 180 degrees. Here, 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees on both sides of the equation. So 180 degrees will get cancelled, and we left only with x minus theta equals to 0. We added theta to this equation, and we found out that angle x is equal to theta. So this angle is equal to theta. Then we actually focused on triangle BCQ. We have here angle CBQ is a missing angle, and we know that the sum of the angles in triangle BCQ must be equal to 180 degrees. So this angle that we define as angle Y plus angle theta plus 90 degrees, in total they must be equal to 180 degrees. I will repeat again, in the right triangle, triangle BCQ, angle Y, the missing angle, plus 90 degrees plus angle theta, in total they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle Y plus theta equals to 180 degrees minus 90 degrees is 90 degrees. Then we subtracted theta from this equation, and we got that angle Y, the missing angle, is equal to 90 degrees minus theta. This angle, the missing angle, is equal to 90 degrees minus theta. So you can see from the drawing the triangle CBQ, the right triangle CBQ, and the right triangle, triangle ANO, are both have the same angles. Both triangles have angle theta, both triangles have angle 90 degrees minus theta, and both those two triangles have 90 degrees. So because of the fact they have the same angles, they are similar to each other. Okay? They are similar to each other, so you can write down the triangle AON is similar to triangle BCQ according to angle similarity rule. And from angle similarity rule, And from the fact that those two triangles are similar to each other, we derive that CQ over AO is equal to BC over NO. Okay? From the fact that those two triangles are similar to each other, we derive that CQ over AO equals to BC over NO. But CQ is equal to R minus A. AO is equal to A. BC is also equals to A. And ON is equal to R. So in conclusion, we found out that according to equation number 1, R minus A over A equals to R over A. So here we have R minus A over A, that is minus 1. So we can write down that R over A minus 1 equals to R over A, because minus A over A is minus 1. We did it and we got that according to equation number 1, R over A minus 1 equals to R over A. Okay? But what is if we focus on triangle BCQ? In triangle BCQ, actually not in triangle BCQ, but in triangle AON, it is very easy to see that tangent theta equals to R over A. That is to say, we can substitute R over A by tangent theta. Okay? So here we substituted R over A by tangent theta. So we got that R over A equals to tangent theta minus 1 equals to R over A. But R over A is equal to 1 over, actually it is A over R. Equals to A over R, but A over R equals to 1 over R over A. So, and we got here that tangent theta minus 1 equals to 1 over R over A is tangent theta. So we substituted R over A by tangent theta, and we got that according to equation number 1, tangent theta minus 1 equals to 1 over tangent theta. We multiplied the equation number 1 by tangent theta, and we got that tangent theta times tangent theta is tangent square theta. Tangent theta times minus 1 is minus tangent theta. And we subtracted 1 from this equation. So in conclusion, we got the tangent square theta minus 1 equals to 0. So we got here a quadratic equation. Okay? And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to a special formula for x, and the special formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 1, and the coefficient c is also equals to minus 1. So we put the data inside the formula for x, and we find out the value of tangent theta because of the fact that x equals to tangent theta. The variable that we are looking for is tangent theta. So we got here the tangent theta equals to minus b, b equals to minus 1. So minus b is minus 1 is plus 1, plus minus square root of b squared. B squared is minus 1 squared, it is 1. Minus 4 times a is 1, c is minus 1. Over 2a is 2 times 1, that is 2. So we got here the tangent theta equals to 1 plus minus. Inside the root we have 1 minus 4 times minus 1 is 4, and 1 plus 4 is 5. So in conclusion, we found out that tangent theta equals to 1 plus minus square root of 5 over 2. So we have here two solutions that are possible for tangent theta. The first solution for tangent theta is the tangent theta equals to 1 plus square root of 5 over 2. That is a positive solution. And the second solution is the tangent theta equals to 1 minus square root of 5 over 2. This is the negative solution. but because of the fact that we have here in the drawing, we have angle 90 degrees minus theta. From the drawing you can see that this is a positive angle. So from the drawing we can write down that angle 90 degrees minus theta is a positive angle here. Angle 90 degrees minus theta, it is a positive angle, it is greater than 0. We added to this inequality theta, and we got here that theta is smaller than 90 degrees, but it is greater than 0. And when the angle is greater than 0 but less than 90 degrees, then the tangents, the function tangents is a positive. And because of the fact that tangent theta is a positive number, and we got here the solution that is negative, here tangent theta is negative, therefore this solution is incorrect solution. We cancel this solution and we left only with the solution that tangent theta equals to 1 plus square root of 5 over 2. So if tangent theta equals to 1 plus square root of 5 over 2, that is about 1.61, then we will use the inverse function of tangents, the opposite function of tangents, in order to find out the value of the angle itself. So if tangent theta equals to 1 plus square root of 5 over 2, then the angle itself theta will be equal to 58.28 units. 28 degrees. So in conclusion, we found out that the missing angle, the angle that we are looking for, that is to say this angle, angle theta, is equal to 58.28 degrees. Okay, thank you very much.